Hello, everybody. Thanks for joining what's going to probably be an incredibly engaging exposition on Portfolio GPT from UNDP. So this is going to be a wide-ranging presentation that looks both at the use case itself for the first half and the second half looking into the technical details. So we're going to have two Q&As and would love it if you would ask your use case and business case questions for that first one and hold all your technical questions for the second half. But first, I'm going to give you a little bit of an introduction about why we're here. So the project is called Portfolio GPT, and it is an AI-powered agent with a reasoning model, which is designed to assist UNDP country offices and their partners in applying the UNDP portfolio approach across a wide range of complex developmental challenges. And so the UNDP portfolio approach, which I'm sure you'll hear more about, is a strategic framework that enables UNDP to deliver integrated solutions to multidimensional development issues such as poverty, inequality, climate change, and governance. And there's a link in the chat if you want to look more into their approach. The concept behind Portfolio GPT is that they're leveraging an expandable database that draws on multiple knowledge bases. And so it can handle complex tasks related to designing, implementing, and evaluating portfolios. So this includes identifying interconnected development issues, formulating comprehensive strategies, and monitoring progress towards the desired outcomes. And this Portfolio GPT was developed internally within UNDP, and it can be customized to address specific use cases. And this adaptability ensures that country offices and their partners can tailor the tool to their unique contexts and priorities. We're having two fantastic speakers, Andy and Vid, and I would allow them to introduce themselves if they would prefer, unless they want me to. But otherwise, I would just hand it over to Andy to get started, as I'm sure we're going to have a lot of content and a lot of questions.
Thanks so much, Rose. Yeah, hi, my name is Andy. So quick introduction before I pull up the slides. I'm a member of the Regional Innovation Team in Istanbul of UNDP, working on portfolios, which is the topic of the day, and also technology, data, digital transformation kind of topics. And I'll walk you through the first part of the presentation today, which is all about sort of explaining the why, the what, and a little bit of the how of Portfolio GPT. And maybe quickly hand it over to you, Vid, and then get started.
Well, thanks, Andy. Yes, so I'm Vid Stimac. I work together with Andy on this project and the rest of the innovation team and UNDP Serbia's tech fellow. I'm a project manager in the UNDP Serbia country office, and I manage the government AI project and usually work on emerging tech. And this is part of our internal work on developing chatbots and using AI for tasks within UNDP. So I'm very excited to present all of this stuff to you guys.
Yeah, thank you, Vid. And it's exciting. So we're talking about something that we're currently working on, essentially. So let me just show you the slide deck so you can see what I'm talking about. Vid, just give me a thumbs up if you can see my screen. Slide deck. Okay, excellent. Okay, so this is what we call it, Portfolio GPT, and how we're building it, what we're learning. So essentially, this is as we build it, we're sharing some of our insights here and how we go about it. So I'll show you quickly sort of the content of today. Is not so much an agenda, but more sort of two sections really. One is, what is Portfolio GPT? What is the portfolio approach? So I'll talk a bit about what it actually is, so you get to understand sort of what Portfolio GPT actually is built on. Then say a few words about why we are investing into Portfolio GPT, why we're building it, and then also say quickly a few words about how we're doing it. We then stop for a quick Q&A, a quick poll, before I then hand it over to Vid, who will say a few more words about different technical sort of aspects, as you can see here. So for some of you who are not familiar so much with the tech part, Vid will hopefully explain, or certainly explain, the details of it and make sure everyone sort of learns about what's actually under the hood of Portfolio GPT and maybe similar agents. All right. just briefly before we go into a portfolio approach, I just want to quickly show you what we as a regional innovation team work on when it comes to generative AI. So we do three things mainly. One is explore, so specifically around using AI for foresight, particularly futures work. So we use a lot of generative AI video, audio, visual content to produce speculative futures that we then use now foresight work with different teams and partners. So instead of giving them sort of a piece of paper where the scenarios or the potential futures are written down, we produce videos based on sort of these scenarios. They're quite immersive, and they've been quite useful so far in sort of engaging participants in thinking about different futures and potential implications. That's one. Second one is training. So we just started conducting a couple of trainings just a few weeks ago. We did this one here, as you can see pictured in Istanbul. There's huge demand for these trainings. So we run that training specifically when it comes to working with text, not so much visuals, video, audio, code, etc. But as you know, as UNDP, we work a lot with text-based materials, and so this is very focused on text. And then thirdly, as you can see here, and as we're going to talk about today, build. So we're trying to build applications in-house. But yeah, we'll talk about this in a second. All right, a few words about portfolios. So I would assume that some of you have heard about the portfolio approach, others have not. Most of us who hear about portfolios think about investment portfolios, right? Where you have different kinds of assets in your portfolio. But what we're talking about here now is really an approach that is very new to some extent, very different from sort of a standard way of working, which is mainly around sort of projects and programs. And portfolio is really about sort of trying to tackle complex challenges where there's no sort of single solution, right? So you can see here an example of a portfolio. This one from Batumi in Georgia. You can actually see the link here, or you can Google it if you want to find out more. There's an entire blog post around it. It shows sort of how we're trying to address or how we're trying to sort of support the startup ecosystem Batumi through different types of interventions. So I'm not going to go into much detail on the different dimensions, the different interventions, the positions, as you can see here in the visual, but just to say that it's these complex challenges where there's no single solution. We're trying to find different ways of sort of engaging, intervening, sort of to push the system towards sort of a desirable sort of state. What's really important to understand for portfolio GPT is that the portfolio approach is very sort of comprehensive, right? It goes from understanding what's currently going on in a certain system to looking at, generating different interventions, to trying to, build political will, to go beyond sort of projects and single interventions. So it's very big when it comes to sort of the knowledge that you need to actually be able to design, implement, and sort of run these portfolios. And you'll see this later when we talk about knowledge bases. But just for you don't have to understand all the details of it. But what's important here is that it's really sort of big in terms of the corpus of knowledge that you need to have to actually design or run these portfolios. Briefly, the other important part is that these portfolios, the portfolio approach is now being implemented and applied across the world, essentially. And this is for UNDP offices. But as you can see here, it's not just a single region or a single country. This is being rolled out across the globe, essentially. And so there's a huge demand for support on how to sort of apply the portfolio approach. That's the second sort of important one. Now, sort of taking all of this, let me just quickly talk about sort of the why we're building portfolio GPT. As I already said earlier, there's huge demand for sort of support on how to design, how to implement, how to evaluate, how to finance, how to communicate portfolios. And we're quite a small team. So there's limited sort of resources, time, capabilities to actually support and work with all these teams. So this is one of the reasons why we said, why don't we have a sort of a customized solution, portfolio GPT, to help us sort of fulfill that growing demand. The second one is, yes, we know there's custom GPTs, OpenAI, all these kind of things, sort of external solutions. But the problem with that is, as probably most of you are aware, one, if it's not sort of internal, the data will go somewhere and it's not sort of doesn't follow the data privacy rules and regulations we have. Two, these custom GPTs are not always 100% sort of scalable, and they're also not sort of customizable to very specific use cases that we have within UNDP when it comes to applying the portfolio approach. So those sort of standard custom GPT solutions, we experimented with them, we used them to some extent, but we realized quite quickly that they are not sufficient for what the kind of work we need them to do essentially. The third reason is why we're building GPT or portfolio GPT is it's an excellent learning experience. So we're learning so much from the past sort of 3, 4, 5, 6 months working on portfolio GPT, how you can actually build AI tools within the organization with little sort of external involvement. And we intentionally didn't want to sort of outsource that, because this is something we as an organization, we as a team really need to have and sort of know about and know how to do, because what we see happening is that there's just growing and increasing demand for AI sort of tools within for our work that we do with partners. Now, I'll show you quickly what the tool looks like, how it works, what it can do, before saying a few more words about sort of the building process. So let me quickly switch to this other screen here. Please tell me you can see the portfolio GPT. Thumbs up. Okay. All right, so this is what it looks like, and probably this will seem familiar to you because this is essentially sort of a chat user interface, right? This is what it is now. It doesn't have to be that way. We'll talk about sort of use cases later, but for now, this is sort of our base bot. We call it base bot because essentially this is sort of the first version, the proof of concept. Now you can see here, similar to sort of ChatGPT and all these other tools, you have a sort of a message chat box here, but you also have sort of proposed sort of questions or prompts you can put in there. So when I click on one of them, say compare sense making and community listening, which are two very specific sort of methodologies within the portfolio approach that we use for understanding sort of what's going on, for sort of interviewing, making sense of sort of certain problems and certain sort of interconnections. This is sort of the types of methods we use. And as you can see here, sort of it gives you an explanation, definition of what sense making is, what community listening is. It explains sort of the differences, and it also gives you the sources. So it tells you these are sort of the documents or the data that we used in sort of generating that response. Now, and we'll talk again about this later, but essentially, portfolio GPT is not just sort of a search engine, or it's not just sort of a single knowledge base. It's not just a chatting with your PDF, but it can actually do much more than that. So I could, for example, ask it, okay, fine, now I know what sense making community listening is. Now give me workshop design for, say, sense making. So this is really broad. And for those of you, who use these tools, know you need to be more specific, provide context, et cetera, et cetera. But just as a sort of a test, let's see what it gives us. It's probably going to be quite general and abstract, but it's just important to say that it's not just about, a better sort of, again, search engine. It can actually do stuff for you. It can actually generate, designs, documents, trainings, et cetera, et cetera. So this would say, okay, you need to go through this and that, et cetera, et cetera. It would sort of require, or it would give you the sources, obviously using the sense-making protocol, workshop, blog posts, et cetera, that we have, the guides, and show you sort of how it's done. Okay, I'll stop here, go back to the slides. We'll talk probably later a bit about what else it can do, or what we want to do in the future, but this is sort of the basic functionality of what we have for Portfolio GPT. I can go back to the landing page. I can obviously ask many more questions or add many more prompts, depending on what I wanted to do, essentially. All right, just put this up here. Okay, this was a very quick demo. We will, I think, show you later a bit of sort of demo on the back end, but let's move on. So you see a couple of examples here. So we put them in the slides, so you get the slides after the presentation, from what I understand, so you can look them up here, just to make sure they're here. a couple of more examples, give us example of a portfolio approach being applied in certain topic areas, sustainable tourism, etc., etc. So it has all of that because of the knowledge bases we provided it with. But again, we'll talk about this in a bit. Okay, so what is portfolio GPT really, and what is it not? So as I said earlier, it's not just a search engine, not just a sort of a bot that can chat with your documents, but is a sort of very smart helper. And you'll see that later when V talks about how it's sort of set up, how it's structured. But essentially, it has sort of functionalities that where you can sort of with that sort of scalable, expandable, that can sort of pull in different tools, be it a simple calculator or web search or some sort of database engine that makes it really powerful. So it's again not just trying to sort of understand what's in a document, but it's actually really helpful in building and designing stuff when it comes to a portfolio approach. It's really sort of still a tool, but that gives us really sort of the superpowers. But obviously, and I think it's important to say, it won't replace any of us, because this is really about sort of a human-machine collaboration, because you can't just say, well, design a portfolio for me or design this and that for me, and then it does that. It won't do that. It needs sort of a back and forth, an engagement, sort of an interaction with the tool to actually give you what you need. So that's the second important point. The third one, as I said it earlier, it's internal, it's customizable, it's safe, data privacy, data protection, etc., both in terms of the documents and the content we upload, but also in terms of the interactions that users have with the bot. And fourth, I mentioned it earlier as well, it's really an opportunity for us to generate that unique learning when it comes to AI tool building and deployment. All right, let me briefly talk a bit about the next steps. So we have this, as we refer to, a base bot. It can do a couple of things, but it's not great yet. It's not really sort of integrated in our sort of workflows yet. So what we're trying to do now, what we're doing now, is sort of refine it to be able to tackle specific use cases. You can see one here, maybe a learning buddy that helps you learn about the portfolio approach. It walks you through sort of certain steps. It designs quizzes for you, custom, based on your sort of understanding or level of sort of knowledge about portfolios. Or it will help you, design the sense-making sort of workshops that I showed you earlier. Or it can sort of help you communicate about portfolios. So we're now trying to sort of refine the bot in such a way that it becomes really, really useful. And so we're doing that with teams across UNDP. Okay, I'll stop here for a quick Q&A, hand it over to Rose, I think. And yeah, thank you.
Yeah, excellent. Thank you, Andy. And this is extremely exciting in terms of Portfolio GPT, and I'm sure many people are going to want to know more. I see 2 questions are posted in the Q&A, and to remind people about where to go, there is a Q&A button at the bottom, and if you don't see it, click the 3 dots that say more and go to Q&A. The first one I'd like to call out is by Wei-Wen Tran. Would you like to ask your question live?
Sure. Yeah. Thank you very much for a very interesting presentation. And my name is Quinn, and I'm working for UNFCCC. And we also have similar use cases which we would like to apply this approach. We have a lot of legal documents, for example, and we think that would be very useful for us to develop like a GPT to help our experts to assess the knowledge when they're on the field, for example. And I just want to understand more from you some context relating to the resources needed to build the portfolio GPT. For example, like in terms of human resources, expertise, infrastructure, finance. If you could shed some light, it would be greatly appreciated. Thank you very much.
Yeah, I think that's sort of a bigger question. I'll try to answer parts of it and then hand it over to Veed for some more of the technical parts. So one is the knowledge base or knowledge bases sort of for portfolio GPT. we have different types of sort of knowledge around sort of portfolio design, examples, certain sort of policies, etc. So we split them up and put them into different buckets essentially. That requires, surprisingly, quite a bit of work to actually source those documents, make sure they're actually readable, then the whole sort of converting that to sort of formats that the machine can actually read and use. That takes quite a bit of time. It's also really important, and that's why I think we're both here, Vid and I, it requires very technical expertise, but also sort of subject matter expertise. Because if you don't really understand sort of why you need to have it in such a way of sort of describing what a portfolio is or how it works or what it does, if you don't have that expertise or actually experience of applying that approach. So it requires that human expertise, it requires the data or the information, the documents, the knowledge, but also requires the whole sort of hardware and software when it comes to generative AI. And I hand it over to me to talk about this maybe.
Yeah, and thanks, Andy, and we can go into more detail a little bit later. I see a question as well here by Alexander. So, this is built on Azure, right? So it's covered by our legal agreements between UNDP and Microsoft. And it's as safe as your email. It's logically divided, like separated from Microsoft, right? So if you trust them with your email, you trust them with this as well. In any case, it's legally covered. Right now for the prototype, we sometimes switch between OpenAI's API service or services that we have on Azure as well. So like the final version, which will be released to users, will use the API service on Azure. The OpenAI service on Azure. So it's all going to be inside the organization, and that's the compliance part. So yeah, and in terms like Andy said, there's a lot of soft work. I always like to explain it. So like all of these chatbots and tools, especially because they process information, they don't just let's say shuffle information about like IT, IT infrastructure. They process information. So any work with them requires a lot of work with people, right? So just like, it's not just a computer, it's more like a cyborg arm, and you can imagine it has to work on both ends, right? Both the flesh part and the robotic part, to put it a little bit graphically. But we'll go later into more technical details, so if people are wondering about what it takes to get this up.
Fantastic.
Thank you very much.
I think I have time for one more business case question before we go into the technical case, looking at the Q&A. Ricardo Rendon Cepeda, do you want to ask your question?
I think mine's more technical, Rose, but I think even from a business perspective, I can convert it a little bit. So this is probably the first practical application I see of AI agents, which is very, very cool to take it from the research to the actual usage. So from a business case perspective, like how did you deem that a simple, like let's say RAG architecture wasn't enough, a simple chatbot wasn't enough, and that an AI agent had to be built, and essentially what features make up the AI agent to fulfill the business case?
So I lead with that in my part. So we'll get to all of that. And if afterwards it's unclear, I'm more than happy to answer any follow-up questions. But I literally go through that, starting with why it's not a RAG and why it's an agent. And by the way, just to speak to the practical applications, I think that the agent applications are really limitless. Really, that's where the tire hits the rubber hits the road, actually. But we'll get to all of that. And so be sure to follow up with your question if I don't answer during my presentation.
Excellent. Maybe we should jump right into the presentation then and see what gets covered.
Right. Okay. Thanks. Yeah. So let's get to it. First, I'll ask you all to let me just share my screen. I will ask you all to go to this poll and fill that out, if that's okay. You can just click the QR code or go to menti.com, and it's just some questions which are going to help me understand what let's say the base knowledge is of the of the audience, so I know where to spend more time and where less time. So I think we'll leave that for a few minutes, and so yeah, I just want to repeat and kind of emphasize what Andy said. Right, we've been working with these tools for over a year, and generally also in our country office. And also to your question, Ricardo, like the best way to make sure that you have a practical application is to start with a use case, right? So if you take a look at, you probably saw agents on the internet, and you know, when programmers do that in isolation, all the agents search the web and write a blog post, right? But only once you get to more comprehensive or more like really focusing the problems that your organization is trying to solve, you know, use cases become apparent. I mean, I'm not going to show it here because we don't have time, but for instance, I organized some agents to do a long listing process using actual TORs and actual CVs of applicants. And it did that with very complex CVs, like, you know, distinguishing between front end and back end engineering, stuff that you cannot always, let's say, expect HR to be able to do. So again, I think it is, you know, and the idea here is, you know, with this presentation, is that we learned a lot of things, like Andy said, by just playing around and being forced to solve problems as they arose. And the idea here is also to kind of like share all of that with you guys. Let me see, am I going to see the results here? Oh my God, there's no result there. People are answering, right. No, I did it wrong. Andy is the more experienced workshop person.
We just go back to the results there.
Right, here we go.
Yeah, you have the summaries, yeah.
Okay, excellent. So we have a lot of daily users of chatbots and weekly users. That's excellent to see. And we also have people who rarely use it, but I'm sure you're going to use it more after this presentation. Over half of people use it daily. Yeah, I've been using it daily since they came out. We also have a lot of people using paid subscriptions, which is also interesting. That's going to follow up because, I mean, you guys who are using paid subscriptions already are actually interacting not with simple chatbots, but with agents every day. So, you know, ChatGPT, the paid version, is an actual agent underneath. See, a lot of people tried custom GPT. That's great. And a lot of people know what a RAG is. That's also great. Custom GPT, where you can upload your documents and make them searchable through chat, is an actual RAG or retrieval augmented generation system. There's also people that know agents. This is also excellent. And we have a lot of people working with, whose colleagues work with relational databases. So once I show the SQL agent people, so this is excellent. So we have a crowd where a lot of people also, you know, are a little bit more technically advanced. So you know, it makes sense to cover both the less technical and the more technical part. Again, the idea here is, so thanks everybody for participating in the poll. The idea here is to go through what we used under the hood. And as we already announced, these are agents. So just generally speaking, building any type of chatbot, there's 3 levers that you use to basically train, no, let's not call it training, right? To get the chatbot to do what you want, right? To answer the type of questions that you want in the way that you want. Right, so there's knowledge management, what Andy talked about. This is really picking the various document bases that or data sets that the chatbot can actually access in real time, right? So this kind of controls, you know, the types of questions it can answer and the information with which it will answer. Then there's the prompt engineering. Prompt engineering is designing an intricate set of interconnected instructions for the large language model that actually steers the way that it is answering your questions. And then finally, I mentioned here also fine-tuning. That's additionally training the model on specific tasks in order to improve performance and cost efficiency. So I just added that for good measure, but right now we're not doing any fine-tuning. So the solution that we're building, that we've built and that we'll continue to build, rests on both, as Andy said, on you know, carefully curated document bases and you know, put in separate buckets and, you know, clearly marked, and in prompt engineering, which is the chain of thought, the reasoning model underneath, and actually, you know, the fun stuff in the model. Right, so look under the hood. So Portfolio GPT is not a simple retrieval augmented generation system or a RAG. So this is usually what you get when they tell you you can chat with your documents, you have some chat, you know, interface, and it gives you a type similar answer to what Andy got on his first ask, usually a little bit more boring, with references. So it basically does a search, and I'll show you how it works in a second, and retrieves documents. So this is a very interesting system, and we're using it, but we're using a little bit more of a complex setup here. So it's a scalable agent-based architecture, and it can handle complex analytics, interactions with other systems, and it can actually also search your document base, right? So you can also chat with your documents, as you have seen. So a regular, I mean, and this is quite interesting because a lot of people now, you know, a year ago, nobody knew what a RAG was, and now everybody and their grandma is building a RAG. So it's good to know what it actually is. This is the structure of your standard, for instance, on Azure, but this is also how custom GPT works. The user asks a question, the query is passed on onto a semantic search. So it's searched by meaning through the document base. It doesn't look by keywords, it looks by meaning. So canine, hound, and dog are going to be very similar to each other. So this is a very important power-up. It pulls out these snippets of information from the document base, and then it uses the language model to formulate that into a coherent, right? So it's a system that passes on your query, searches for a bunch of search results, and then, because it gets all of these search results, it kind of meshes them together into an acceptable answer in natural language. So this is a basic retrieval augmented generation system, as you will see them. The issues with RAGs in general is that they're not very scalable. So first, there's limited reasoning capacity. You're going to see with them, you can maybe change the language, etc., but they're usually instructed to stick to their knowledge base and not improvise too much, right? So you cannot ask it to write you a haiku or do some analysis or compare different knowledge bases and the like, right? So it's a very basic, the model is used like AI. Okay, AI is used with a search because of semantic search, but it's primarily the let's say, OpenAI service is used to process the search results. So these are regular RAGs. It's also very unstable at scale. So once you add and increase the document base, or it starts mixing everything up together, because at the bottom, at the bottom of it, it just looks for things with meaning. So as if you unless your knowledge base is extremely homogeneous, if it's different and topical, if there's certain hierarchies of information present, and you just put them all in one bucket, you're going to get a less relevant results, and you're going to get hallucinations, right? Because this is how it's elucidated. And finally, it processes documents and tag documents as well. So it cannot actually interact with other systems. And in that way, it cannot actually solve any tasks, right? So moving from that, we move to agents, right? So agents are basically frameworks, and don't worry, so bear with me right now. We're going to get to a lot of examples. You're going to see prompts. You're going to see them at work, etc., etc. It's going to be much clearer once we get to the nuts and bolts of it. But just on the higher level, these are frameworks that connect the reasoning capacity of language models with actions, right? Such that the language model all of a sudden can interact with the outside environment. So it can do a web search, it can perform some calculations in a calculator, it can execute code, call an API, etc. So here, if you see it, the LLM, then the language model executes a certain action, right? So it, for instance, performs a web search. It sends the search terms to the web, and then it observes the results, right? So the results from the web search, right? And then it can actually, iterate until it can solve a certain task. So again, I see that over half of people have paid GPT. Paid GPT, right? OpenAI's GPT-4 is an actual agent, right? So let's just ask it to confess. Give me a list of functions that you're able to call from this environment. Please list function names explicitly with accompanying explanations. So there's a bio function that they just added, where it adds a little interesting information about you to be custom. There's the DAO-E text to image function that can generate an image once you've actually asked it to do so, right? So this is not happening in the language model. This is happening outside of the language model. There's the browser function in GPT-4. It allows the search, right? It also has a function to click on links, so it can browse the net, and to open specific URLs. By the way, this is a hack. If the GPT-4 doesn't want to open your URL, you just give them an explicit instruction to do so. And there's also, an environment for executing Python code, right? So this is when it does data analysis or it executes code that you asked it to run, right? So in a way, not in a way, but this is already an agent, right? Underneath. It's not an autonomous agent because the LLM executes an action, and then you, as the user, observe the result and instruct the model further. I don't like this image, make me a new one, and then it executes it again. But you are already, like all of these, let's say, multimodal chatbots are already actually agents. So let's talk about how these agents, so they can act, right? So we saw that we have a model that can act and then can observe the results. But as you can see in normal GPT, the user is the one who evaluates, right? So we need some other element here. We need to explain to the model how it should reason. So there's a reasoning and acting chain that we put in, and these are prompt instructions again, and I will show you a concrete example that structure the agent's approach to executing the user's query using the tools at their disposal. And it also adds the final condition, because at one point, the agent has to be done and conclude that it has answered your query after using all the various tools and to give you the result, right? So here's one model, and this is a model by Google Research. It was published in 2022, the React model, which combines reasoning and acting, right? So I give the agent a task. The agent first starts thinking about the task. Then it executes an action which it thinks it can help it solve the task. It observes the results. It then thinks again if it needs to, or executes further actions that it planned to do, until it iterates to the solution of the question, right? So I will show you, and I hope you can read this, guys. Is this readable? Hopefully it is. This is the actual prompt that we give to the agent. This is the React prompt published by Google Brain Lab, and I guess a couple of colleagues also from Computer Science Princeton. So we're basically giving it a reasoning frame, right? And let me dissect this reasoning framework. We say, answer the following questions as best you can. You have access to the following tools. It's provided a list of tools, and you will see in a second what these tools are. They're different per different agent, but this is the basic prompt. And it says, use the following format. There's a question. You put a question there. There's a thought. Think about what you will do. And then there's the action. And then the executing of the action itself. And then you observe the results. And then there's a chain until you find the final answer. Here's the list of tools. This is, by the way, what they refer to as multi-shot learning and prompting, right? We give it already the structure of the answer we want it to get. And then we basically, the user's question is inputted into this prompt, and then it starts thinking and acting and observing below, right? So just to demystify, this prompt engineering aspect, it's basically a template, a textual template with instructions that gets inputted and then sent again to the language model so it can continue reasoning. So let me just, right. So how did we solve our problem, right? We couldn't use a RAG. As I said, we couldn't use a RAG because of the, there's various methodologies in the portfolio approach. They use similar terminology, but in different contexts, it means different things. And there's also quite a wide range of different topics, right? Even in the baseball array. So what we basically do is, rather than having the user's query passed on to the knowledge base, we pass the user's query on to our agent, right? Who has a prompt, remember, like this. And then the agent starts thinking which of the knowledge bases it would need to use to answer our question, right? So there's 6 knowledge bases here. There's a general background to UNDP's portfolio approach. There's the portfolio approach program and operations policies and procedures. Right? There's the sense-making knowledge base, the community listening knowledge base. These are methodologies. There's experiences and use cases. So this is something that the agent in the follow-up questions that Andy passed through called on to pull out actual use cases that are being used. And then there's also methodological parts and steps to develop a portfolio. We can also ask the same question like we asked GPT-4o. And indeed, unless it crashes, it actually will oblige and say. It has a calculator, it can search portfolio policies, it can search portfolio sense-making, knowledge base, it can search 1, 2, 3, 4, 5, 6 different knowledge bases to answer a question. So, 1 second. Yes, so let's try that. So you recall that Andy asked the first question, right? In the portfolio approach, sorry. It was compare sense-making and community listening and tell me when to use which methodology. This is a little bit on the back end, but this is so you can actually see the reasoning chain. This is important. It starts. I need to gather information about sense-making and community listening methodologies within the context of the portfolio approach to provide a comprehensive comparison and guidance on when to use each. Again, it starts with reasoning, right? Then it will execute an action. It did a search for sense-making, and it searched sense-making methodology. It got a bunch of results back which are for us gibberish, but this is like a calorie food for the chatbot. It has a lot of information on sense making and bits. Then it decided it also needed to investigate portfolio listening, and it did another search, got a bunch of other answers. And then it concluded that it did enough searching. And then it used all of this information to draft an answer and to also add references to where it got it from. And these references are the things that get connected on the front end to the actual document. Right? So as you can see, it followed the chain of reasoning to answer Andy's question. That's also why it took a little while. But using these chains of reasoning really reduces hallucinations and ensures that every single tool is sequentially used. You will see it again later when we talk about relational databases and how they're used. Right. So, and then I'll move on to the second agent, and I think I'll try to go through that relatively quickly. But here we have another agent. So it doesn't need to be the one that we used before. This is an agent that we built, that I built on the side when prototyping and seeing how we can actually use it, not to search semantic databases, like not to search documents, but actually to search relational databases and to actually be able to answer exact questions and add things together and aggregate. Right? So we have an agent here, which I will show the prompt of in a second, that can perform 4 different actions. It can inspect the database that it is connected to. It can inspect the table structure. It can check the quality of the query sent to the database, and it can also send the query to the database. And then it can observe the results of the actions and do this again, or terminate the chain if the question is answered. All right? Right. Again, there's a prompt for this. We don't need to go into details, but you're an agent designed to interact with the SQL database. It's passed on which type of SQL dialect it's used. There's also instructions for using the tools. You must double check your query before executing it. If you get an error while executing your query, rewrite the query and try again. So even when it blows up, this agent doesn't go offline. It just tries again, just like a human to solve a problem. And then, for instance, there's also some guardrails. So this is in practice how within the prompt guardrails look like. Do not change the database, do not delete rows or columns and the like. And then you also have the following table. So it's passed on the design of the database itself. As like I said, it had 4 tools at its disposal. There's a tool that takes an SQL query and retrieves data from a database. There's one that actually provides information on the structure of the tables, so it can actually design its queries. There's one that lists the tables available in the database, and there's one checking the actual query. So these are 4 tools that the data analyst would need to use this tool. So let me show you how that works in practice. And just again, I think this is weird because I actually had the database here. This is odd. So I actually, the database are connected. I mean, for those who are familiar with these, hold on a second. It's an open source database often used. Hold on. Did it open? Oh, here it is. Right, so it's a database on sales, right? So it has a couple of tables inside. There's a table about invoices. It has a table, it's selling records and then information about the records, which albums, which artists, how much was sold, where the customers are from, et cetera, et cetera. So this is your typical relational database, which is connected with a number of keys with each other, right? So this is something that, answering questions about the database of this complexity is something that a junior SQL data analyst would then do, right? So we can actually also, and I mean, these queries themselves, even though large language models are not good at actually analyzing numbers, they are very good in text, and this is basically text. So we can see how big the database is. There's, the artist has 275 rows. There's 3,500 tracks. There's 2,000 invoices. And then we can, for those who are not familiar with querying databases, to just give a quick illustration, you can actually answer analytical questions with these SQL queries, right? So I can, for instance, I'm interested in knowing, how many, from which genre, that's one of the tables, how many tracks there are and how much revenue there is, right? So it needs to connect a number of tables to that. It needs to count the number of tracks. It needs to summarize the the product of invoice and the unit price and invoice quantity, and then it needs to connect to a number of keys to give me this type of answer, right? And then similarly, we can look at which customers spent most and the like and the like. Right. So here comes the kicker. Our agent has now been trained to do the following, or prepared to do the following. So we're going to ask it a complex question relating to this database. Let's say which country's customers spend the least and what is their favorite song. For that song, find the artists and sum up the length of all of the artists' songs. Now, I have in my career hired, interviewed and hired a bunch of junior data analysts, a lot of smart young men and women among them. None of them will be able to answer this question, to write out the necessary queries. As you can see, it's shooting out the queries and it's done. The country's customers spend the least is India, with a total spending of 36.64. Their favorite song is concerto piano, etc., etc. And the artist for this song, and they have a total of 9 minutes and 20 seconds of length. So this is a complex question. We can also ask this if we want. This is a complex question that requires a series of SQL queries to answer using a relational database. And what we saw here is that a simple agent with some instructions and some tools was able to do this with an accuracy and speed which cannot be expected from junior data analysts, even immediate data analysts. So anyway, this is a little bit of a demonstration. This is why I asked how many people work with SQL databases, and then I'll stop here and hand back to Rose. I can put up the slides if it's necessary in a bit. I hope that was terrible.
This was completely exciting and fascinating. So thank you, Vid. And again, thank you, Andy. We have several questions, and reminding people, if you can put them in the Q&A, you will get a slight preference from me so that we have all the questions put together, because then I can manage the flow. I'm going to start with Stephen Wilhite's question about open source LLM. So I'm going to kind of pop this out and then get ourselves back into here. So Stephen, do you want to go in?
Sure. So basically, I was just asking if, or how much of the approach that you guys described, both of you, could be applicable in an environment where you're using solely open source LLMs and that environment is isolated from the internet.
Yeah, so you mean like on-prem, basically using, yeah, so you can do it. It's just that these non-open source LLMs are better, but all of this stuff is moving at rapid speed. So if you take a look at the original paper that the guys from Google Brain Lab and Princeton wrote about the React, they were using some open source very simple Google model. It's just that as these things, as these models advance, they become better. I mean, for instance, the ability to write such good SQL queries comes from the fact that GPT 4.0 has been additionally fine-tuned for these type of things like function calling and the like. So it's actually much more precise, so things will blow up less. But let me put it like this. Building these frameworks, you can plug in what you want, right? So the LLM is basically the brain. So you can develop your entire prototype using paid services, and then at one point then also just kind of fine-tune and fix your own on-prem model and just plug it in. It's literally a different endpoint that you add. The whole prompt just remains the same. The LLM is the brain inside, and you can just hot swap it. Hope that made sense.
Yeah, it did. Thank you.
Dushan, would you like to ask your question?
Yes, thanks, Rose. We did a kind of a pilot recently with the Azure AI search to search primarily the unstructured data, but also during the process I realized the Azure AI search can also link to the Azure SQL, like relational databases. I just wanted to know what this approach differs from that. Sure. Thank you.
Yeah, so Azure AI Search is a very nice packaged tool right? So you index it in this embedding database, and it becomes understandable for AI. So it's an excellent tool to use. As for indexing databases, I'm not that happy with their solution, because basically they're treating, as far as I know, like for indexing actual data, we use that in some applications, but very sparingly. They basically treat a database as a bunch of documents, right? So you get kind of a semantic search of a database. The difference here is that there's, and then you're limited by the number of results, you're limited by the recall of the model, the extent to which it is able to synthesize it. The more things you add, the more different they are, the more, let's say, bland and irrelevant your results become. So this is something that I would use sparingly. It seems more like taking a sledgehammer to it. What the agent here does, it writes actual SQL queries, right? So there's a database, and it just really does a SQL query on it. And these models have become so smart that they're able to write really complex queries much faster than humans can write them. So in this sense, it's actually accessing the database and pulling out exact information in the format that you want it, rather than relying on semantic search and indexing. I don't know if that makes sense. So again, as far as I know, Azure AI search generally works with either keywords or with embeddings. So either semantic search or keyword search. And when they actually, applied to databases, maybe they added something new and I haven't seen it, but when they apply to databases, they basically treat databases as collections of documents. So it's, but generally speaking, as a tool, like for instance, we have, we use Azure AI search within our agent uses Azure AI search to actually perform the searches and retrieve the snippets of information from which it constructs its answer. That makes sense.
Thanks, Vid. Yeah, it makes sense. Thank you.
Great. Can we hear now from Nelson James?
Going once.
Like, okay, I will read it out. He doesn't have like. So Nelson writes, in similar projects, I have seen that when executing the same question, the answer given by the LLM might be different because the SQL queries generated might differ at each execution. Have you evaluated the consistency of your pipeline?
Yeah, so this is a necessary, let's say, necessary evil, right? So you can play with the temperature, right? And usually for these SQL, the temperature, by the way, for those who don't know, is a parameter that tells the model how creative it should be, how wild it should go. So when you're doing stuff, when you wanted to write code and things that need to be very precise, you set the temperature to 0, and it's very deterministic. But when you want it to be like creative and associated, you set the temperature higher. Generally speaking, even when you set temperature to 0, there's some stochasticity in all of this, and these answers will differ, right? This is, you can, let me put like this. This is good for a chat, application, right? So just like you have a very well-informed colleague that can synthesize, assistant can synthesize stuff for you. So it's not terrible if answers differ every time. You want some creativity in there, and you want it also to be able to actually do a little bit more complex tasks for which creativity is necessary, right? Temperature. However, if you were to use this in a production environment, right, where this is one system talking to another system on the basis of queries, where you want actually 0 deviation, there's a lot of ways in which you can kind of like steer it. You can make longer instructions in terms of the methodology to apply, how to build these queries. There's a lot, obviously, output parsers and all of these kind of things to make sure the mistakes don't happen. So when you're trying to use these functionality for machines with machines, there's ways to make it tighter. Here we've observed, like you said, that answers differ. And as you can see, the sense making, the answer that Andy got from the first and what I got were slightly different. But we think this is okay for a bot communicating with humans, because humans will also always give you a different answer.
Cool. Let's get Luong Bangtran's question, and then Ricardo, I see you have several ones. Perhaps you could take the most appropriate. So Luong, about LangChain?
It's all in LangChain, if that's the question.
Yeah.
It is. So we're using LangChain as a framework, but we are editing, obviously, the system prompts. LangChain is a framework for prompt engineering in Python, for those who don't know. And it allows you a lot of these functionalities where you have a prompt with changes with inputs. So these are prompt templates, and then building these on is how you get these big systems of prompts that we call prompt engineering. So LangChain is a very nice framework for that. It's not super stable. You need to kind of polish it yourself, but.
I see someone is also asking, are you using a LangChain SQL agent for the SQL chatbot, or did you create the SQL query chain?
No, I'm definitely using the LangChain. There's a couple of them. I'm using the one with the 4 tools in this context. But again, what I noticed, just, people need to watch out with LangChain. So they build it nicely, but often, like, it's still open source and what have you. A lot of these prompts that are in there, to me, seem like the second try, right? So I come from inferential statistics, from econometrics, and this is also statistics and inference, right? So you robustness check, right? You test the prompts, and like the Nelson, I guess earlier said also, you want to check the consistency of your pipeline. And I have a feeling like these open source things, they just pop it out. So when you're using these frameworks, don't assume that prompt that they use is finished. It was probably the first prompt that worked. So feel free to kind of improve on it and see how it works. You can often get much better results.
Awesome. So Ricardo, if you could go, and then we may have just time for one more question, unless we're going over for Riza. Ricardo.
Thanks, Rose. Thanks, Vid. I'll summarize my 2 questions in one, which is basically coming down to how are you deciding and controlling the autonomy of your agent? Because I see, right now it seems like your agent, basically whatever the user query is, it always tries to complete the action without sort of confirming first to the user if that's the action they want the agent to take. And then on the other one, on the SQL database, like, are you doing any sort of like resource-based access control for the agent so that it can't do operations like delete and just nuke your database, even if, in your prompt, you're guiding it not to. So like, how are you moving towards governing the agent like you would govern a colleague, and what permissions you give them to do things in IT?
Yeah, so I'll jump on the second question. This is obviously still prototyping, and obviously the prompt itself is not the way to stop it. You would just basically take away the rights it has, to blow up the database. So that's the first thing. And the first one that regarding like that you have a lot of freedom in that. So here we just kind of went like, okay, let's get the conversation going, and because it has a chat history. If it didn't do what you wanted it to do, ask it to do what you wanted it to do to kind of keep it flowing. And we're still struggling a little bit with performance. We're now around 20, more complex chains take about 20 seconds, which is slightly, for a smooth interaction, especially, it's too much. But we're working a little bit on that. But the idea is to keep it flowing. Obviously, when you have specialized, and by the way, we have some guardrails in there. We call this the tomato test. So Andy would keep asking it, to explain how to grow tomatoes, and then we would need to put guardrails in, and then finally it refused to answer it in any which way. We were kind of done for this iteration. But obviously, testing it with users is gonna, people are very creative in breaking guardrails. But what you said, like, that might make sense. So the specific use cases that we're looking at in terms of guiding colleagues through certain scenarios, like having it, those are obviously going to have more defined scripts for interaction. Check this, note it there. When you have maybe different states, right? So first, maybe the agent is collecting information from you, and then once it has collected enough information, it switches to another agent mode, right? You can change that with a new, like the state messages variables. You can kind of change its mindset as soon as it completes a certain task. So these are things that you kind of work with the use cases. But again, this is why I'm super excited about the technology, but I do need to hammer in that none of this would be done unless we had a use case to work on. Because once you start looking like, taking the perspective of a hammer, then everything looks like a nail, right? I want to use an agent here, I want to use an agent there. And here we're kind of like trying to, we have a proof of concept, but we're trying to also get specific use cases, from our colleagues that are going to help us kind of decide which of these tools we should use to solve them.
Wonderful. If Riza, if you could ask your question to finish us off, that would be great, bringing it back, I think, more to the business focus.
Thank you, Rose. Thank you for the presentation. It was very friendly and easy to follow, even though I'm not a specialist in these topics. My question is, would you expand this portfolio GPT into other topics, or would you say it's more recommended to have separate GPT? And I wonder what this implies in terms of capacity of the database, also cost and time to build these GPTs. I'm thinking also, for example, I work for the regional office. Let's say we have an area connected to knowledge around results-based management. We can build our own GPT around RBM, but then we have another area, let's say around environment or governance topics. Would you suggest it's better to sort of create an integrated GPT with all these different topics, or is it better to focus on one area specifically? And then the last question, I mean, it's to sort of connect, but it's like in terms of like practicalities, what type of data you need to submit into this GPT? Because I saw the portfolio, I saw that you have these guides, community listening and so on, but for most of the data we have are in different formats. We have unstructured data, we have Word documents, we have PDFs, we have Excel, PowerPoint presentations, sometimes even information from Quantum or like, I don't know, websites. So what type of data we will need to prepare if we are aiming to have a GPT for our areas of work?
Do you want to go, Andy, first? Or should I?
These are discussions we've been having a lot. So I'll answer from a sort of user perspective, then Vit, you can talk about the technical part. So on your first question, or in the second question first, I was very surprised, and Vit can probably talk more about this in much more detail. But we use PDFs, we use blog posts, we use Word documents to some extent as well. The most sort of valuable information or the data was sort of curated learning materials that gives you sort of a step-by-step sort of explanation of what a portfolio is, how it works, etc. Then something that has been less useful is sort of personal reflections of how we design a portfolio here and there. So it's not so much, I think the format is not a big issue, although some of those Miro boards that we have, they don't work so well. But other than that, a lot of different formats work. It's much more the content that is in there, because whatever you put in obviously is what you get out. And this is why I think I mentioned earlier, sort of it's a really unique asset that we have, a portfolio approach, and all these experiences, all this knowledge that we have within the organization is sort of what makes it possible, along with the tech, obviously. Then briefly on his first question, I think we also discussed that when the question is sort of where do you stop? If you want to expand this particular portfolio GPT, expand, you get to a point where we have try to squeeze in all of UNDP knowledge there is into one single GPT, which obviously is nonsense because it would just slow down, which just not be technically feasible. What we decided to do, and this is what we briefly talked about, have these different knowledge bases. So we, even within the portfolio approach topic, we have knowledge bases on different sort of subtopics that makes it much quicker and faster and easier to use the GPT. But that really, I think, again, hand it over to Vit now. It really depends on your sort of specific topic and sort of what information and data exists. Yeah, over to you.
Yeah, so I don't have that much to add because it really depends on a case-by-case basis. In this instance, we were able to find a solution for integrating various databases. Maybe later on we'll find other solutions to integrate them. What you cannot do is throw them all on a pile, right? So that's not going to work, right? And also, I mean, what Andy mentioned, you cannot also just proliferate the tools either. It's like, imagine just having a person that has, they have a desk, somewhere that they have like 120 different forms that you can fill in, like a civil servant, like they would get confused as well. Similarly, the bot will not be able to decide which tools to use. So it's always helped to be a little bit specialized. But again, it really depends on the use case. And I think that pretty soon we're going to have tech that's going to allow these bots to like move from different states, right? So right now it's a bot that helps you with some HR issues, and then you move maybe to another topic and the bot puts another hat on, and then there's a different set of tools at their disposal. That's probably going to work much better, but then you would have to manage jumping from different states. But again, regarding your use case, the best way to look at it, I mean, at the end of the day, this is engineering, right? So you need to try it out and see whether it breaks. And if it breaks, try to make it, to fix it, right? So in a way, it will really depend. Generally speaking, regarding costs, Microsoft Azure is not cheap. The LLM service costs as much as it costs from OpenAI, but the general resources are not cheap. in that regard. So, but it really all depends kind of like on your use case. So if you have a productive use case where you're really like something in operations, so it's not something like, you know, flight to fancy, but something that really, you know, optimizes the business process, then a lot of these costs are really justifiable, because when you actually put in a human's time against costs of these resources, these are factors. These are orders of magnitude difference, right? How much cheaper this is, right? So I had some prototype fine-tuned model to generate scope of work sections, but, you know, according to the right, you know, category, right, with the right words, trained on some TORs. And, you know, even if I do it 15 times, that costs like 40 cents. How much does an HR person's time cost to check it, and then project manager's time to formulate a scope of work section, etc. If it's total like an hour or 2 hours, you know, we can add it's at least $50, $60, $70 against 50 cents, right? So then something which might be expensive, when it actually has an, you know, a direct business implication to business process, becomes extremely cheap, right? So this is how you should always, but yeah, exposing it to the general public and letting them do their homework on it is probably not cost effective. That makes sense.
Awesome. Thank you so much, our colleagues from UNDP, Andy and Vid. This has been an exciting and incredibly informative, and I'm so glad for everyone who hung on the extra few minutes. And so thank you very much. And I hope that this is the beginning of many conversations that continue. And again, wonderful work, and really looking forward to watching as it progresses even further along.
Thank you.
Thanks, everybody.
Having us.